Is the screen visible, guys? Just a second. Is it visible?
Yes, sir.
Right. So we will solve the questions again in today's session of dual nature of matter and radiation. Right. So it's a very important chapter, but we can guess the questions that can come from this particular chapter. The question can either come from dual nature. The question can either come from photoelectric effect, which is direct equation. Maximum kinetic energy will be equal to h nu minus phi naught, which is called as the work function. In the same manner, question can come from de Broglie wavelength, right, where lambda will be given as h by mv or h by p. You can consider. So these are the only two areas where questions can be asked from this particular chapter. So without doing further late, we will just quickly see these questions, guys, again. The monochromatic light of wavelength lambda is incident on an isolated metallic sphere of radius r. The threshold wavelength is given as lambda naught. The number of photoelectrons emitted before the emission of photoelectron will stop. Means before photo current stops, what would be the number of photoelectrons emitted? They are asking. So they have given us a monochromatic light of wavelength lambda is incident on a isolated metallic sphere of radius r. The threshold wavelength is given, right? So what we can find out? Can we find out the kinetic energy from this? Yes or no? So what are we going to get? The kinetic energy or the maximum kinetic energy of emitted electrons by Einstein's photoelectric equation. We can write it is h nu minus phi naught, where phi naught is the work function. If energy of incident radiation is more than work function, then only photoelectric effect will take place. H nu happens to be energy of the incident light. Whenever energy of incident light is more than work function, then only the electrons are going to get emitted and they are going to have certain amount of energy again, right? So we can find the potential from this. So what is maximum kinetic energy? You can write it as E times of V naught. You can write it in terms of what, beta? You can write it in terms of your potential difference or stopping potential, we can say. What is stopping potential? It is the minimum negative potential applied at anode in order to stop the photocurrent. So they are asking how many number of electrons will be emitted before the emission of photoelectrons will stop. So what is the wavelength given as? Wavelength of incident light is given as uh, lambda here, and the threshold wavelength is given as lambda naught. So what we can write here, hc by lambda minus threshold work function can be written as hc by lambda naught, guys. I can also write work function as h nu naught. Nu naught will be threshold frequency. So what we can tell here, EV naught value if I take hc, if I take common, I'll get it as 1 by lambda minus 1 by lambda naught. So from this, what will V naught value? It will be hc divided by E into 1 by lambda minus 1 by lambda naught. Yes or no? We got this particular situation. So you got to know the minimum potential. Now, in order to find the number of electrons emitted, they have given us a metallic sphere. Again, whenever you take a isolated conductor, will it behave as a capacitance or not? Yes, it is going to behave as a capacitance. So what will its capacitance be? It will be equal to 4 pi epsilon naught capital R. You know the capacitance, you know the potential difference. What will be the charge, beta? The charge we can write it as C into V naught here, which will turn out to be 4 pi epsilon naught R Hc divided by E into 1 by lambda minus 1 by lambda naught. Now from quantization of charge, they are asking us number of electrons emitted. How can I write charge as? I can write it as n into E from quantization of charge. 4 pi epsilon naught R into Hc divided by E, 1 by lambda minus 1 by lambda naught. So what are we going to get the value of number of electrons again? 4 pi epsilon naught R into Hc divided by E square into 1 by lambda minus 1 by lambda naught. This will be the number of photoelectrons emitted before photoelectric current will stop. Okay. The monochromatic light of wavelength lambda is incident on a metallic sphere. So any isolated conductor, as we have studied in electrostatics, will behave as a capacitor whose capacitance will be 4 pi epsilon naught R. Whenever wavelength is less than threshold wavelength, lambda is the wavelength of incident light, guys. Whenever wavelength is less than threshold wavelength, photoelectric effect will take place. If wavelength is more than threshold wavelength, photoelectric effect will not take place. If frequency of incident light, if it is more than threshold frequency, then I can say photoelectric effect is going to take place. If frequency of incident light, if it is less than the threshold frequency, then I am going to say the photoelectric effect is not going to take place. Is that clear, all of you? Yes or no, everyone? Right? What is threshold frequency? It is the minimum frequency above which photoelectric effect takes place. What is threshold wavelength? It is maximum wavelength below which photoelectric effect will take place. And the maximum kinetic energy can be written as E times of V naught. This is basic. All the questions can be solved based on this only, guys. Okay. I hope you understood the first question. Let us today's session we'll do the questions of dual nature, guys. Tomorrow we will do what do we say? Atoms as well as nuclei. Tomorrow I'll take a little bit extra session, maybe a 3 hour, 3.5 hour session. Tomorrow I'll be taking for you people, guys. A photon of energy h nu is absorbed by a free electron of a metal having work function less than h nu. Then what is the situation? Electron is sure to come out? No, guys. Always remember, efficiency of photoelectric effect is 1%. If energy of incident light is more than the work function, it is not necessary that the electron should get emitted again, because the efficiency is almost as it is very less efficient. Again, 1% efficiency is there. So electron is sure to come out? No, they may come out, they may not come out, right? Electron does not come out, or it will come out with kinetic energy h nu minus w. Yes, this is correct. It may come out with kinetic energy less than or equal to h nu minus w, right? It is not necessary that it may come out is given, so this may be true again. The electron is sure to come out with kinetic energy h nu minus w. No, this is wrong. Electron is sure to come out? No, right? It may come out with kinetic energy less than or equal to h nu minus w. Yes, because always remember, kinetic energy of emitted electrons will lie between 0 and maximum value. And what is the maximum value? It is E times of V naught. If it is coming out, then with maximum kinetic energy of EV naught, or with kinetic energy h nu minus w again. So what they are saying, this is your maximum kinetic again. Now I cannot say second one is correct. Why? Because second part, if you see, it will come out with kinetic energy h nu minus w. No, h nu minus w is the maximum kinetic energy. There is no necessity that electron should come out with maximum kinetic energy. It will come out with energy less than or equal to h nu minus w. So third statement will be a correct statement. I hope it is clear, all of you. Efficiency of photoelectric effect is less than 1%. So what we can conclude from that? Even when energy of incident light is more than work function, there is no necessity that electron has to come out from the surface of the metal, right? And in order to liberate an electron from the surface of the metal, I need to cross some minimum energy. That minimum energy is called as work function. Whichever surface has less work function, it will be more photosensitive. Whichever element has more work function, it will be least photosensitive. Cesium happens to be most photosensitive because its work function is 2.14 something. Platinum happens to be most photosensitive because its work function is 5.65 electrovolt something. Platinum is most, sorry, platinum is least photosensitive, and cesium will be most photosensitive. Okay, so these points you should be aware again. I hope it is clear. And always remember, if electrons are emitted, they will come out with a energy more than zero, but less than or equal to maximum value of kinetic energy. And that maximum value is given as EV naught, guys. And we can also write the maximum kinetic energy to be h nu minus phi naught. I can also write it as h nu minus h nu naught, which can be taken as h into nu minus nu naught. I can also write it as hc by lambda minus hc by lambda naught, which I can take it as hc into 1 by lambda minus 1 by lambda naught. These are all various cases again. Next case, if you see, the plot of stopping potential and frequency of the light in an experiment, stopping potential and frequency they have given, guys. Now, how will you find out that graph? It is also very important graph, guys. So if you see, we got maximum kinetic energy as how much? We got the value of maximum kinetic energy as how much, beta? H nu minus phi naught. I can write maximum kinetic energy as EV naught, which will be equal to h nu minus phi naught. Right? If I take stopping potential, what I'll write? H nu minus phi naught divided by E. The stopping potential can be written as h by E into nu minus phi naught divided by E, guys. So what we are taking? We are taking stopping potential on y-axis. We are taking frequency on x-axis. So is it going to follow y is equal to mx plus c or not? So what would be the slope here? Whenever you plot stopping potential versus frequency graph, it will follow a straight line. What will the slope be? H by E. This H value is constant, E value is constant. So you take any surface, guys. The slope for all the surfaces will remain constant. And what will be the intercept beta? You will get it as minus phi naught divided by E. Negative intercept again. For different surfaces, phi naught value will be different. So intercept will be different. Okay. Now, if you come back to the question, they're asking us ratio of H by E. What is this H by E called as? Is it called as slope or not? So how will you find slope? You'll just take this point. How much is this point? 6 comma 1 1.656. How much is this point? 2 comma 0. So what is H by E value here? H by is nothing but slope, guys. So how will you find slope between these 2 points? 1.656 minus 0 divided by 6 minus 2, which is 1.656 divided by, what will I get beta? 4 I'm going to get, which will turn out to be 0.414. Now, if you see numerator is in volt, but denominator if you see is frequency again, so I get 10 power 14 again, guys. So in denominator, you will write into 10 power 14. Here again, you'll write into 10 power 14. This will become 10 power minus 14 into 15 by 15, into 10 by 10. If you do, it will become 4 into 10 power minus 4, 4.14 into 10 power minus 15 volt per hertz or volt second you can consider. Clear, everyone? Always remember, stopping potential versus frequency will follow a straight line with positive slope and negative intercept. Okay, right? Slope will be constant for all the surfaces. However, intercept will be different for different surfaces. Is that clear, everyone? And one very important point, stopping potential as well as maximum kinetic energy, they will depend only on frequency. If you talk about stopping potential and maximum kinetic energy, they will depend only on what beta? Frequency of incident light. Whereas when we talk about photocurrent, see, when electron is being emitted, means charge is flowing. Whenever there is flow of charge, there is current. That current in photoelectric effect is called as photocurrent. Photocurrent will only depend on intensity. Photocurrent will only depend on intensity. Will stopping potential and maximum kinetic energy depend on intensity? No. Will current depend on frequency? No. Current will depend only on intensity. Stopping potential as well as maximum kinetic energy will depend only on frequency. If I plot the variation of current versus intensity beta, right, it will follow a straight line passing through origin. Whereas if you see the variation of stopping potential and frequency, it is following a straight line, but does it pass through origin? No. But current versus intensity will be passing through origin, guys. Clear, all of you? Yes or no? Let us see the next question. If the momentum of an electron is changed by delta P, then the de Broglie wavelength associated with it changes by 0.2%. Initial momentum of the electron they're asking. Again, a very important question, guys. Right. De Broglie wavelength lambda will be given as h by mv or h by p or h by root over 2m kinetic energy or h by root over 2m charge into potential difference. If you know these formulae, then you can solve all the questions of your de Broglie wavelength. De Broglie wavelength will be given as h by mv or h by p or h by root over 2mk or h by root over 2mq into v. Here de Broglie wavelength and momentum relations are given, guys. H value, so obviously, you know, it will remain constant. So lambda will be inversely proportional to what? P. So what we can write? Lambda will be proportional to p power minus 1. one quantity is expressed in terms of another quantity raised to some power. So what I can write, beta? Relative error you can write delta lambda by lambda will be, here I'll get minus 1 times of delta p by p. What is minus sign indicating here? Minus sign indicates inverse proportionality, guys. If momentum is increasing, right, wavelength will decrease, right? If momentum is decreasing, wavelength will increase. So what they have given, suppose from here, delta lambda divided by lambda into 100 if I take, you will get it as minus of delta p divided by p into 100. If the momentum of an electron is changed by delta p, right, they are saying by how much, what will be the initial momentum again. So what are we going to get? What is this given as? 0.2%. So I can write zero point 0.2 will be minus of delta p by p into 100. Zero point 0.2 can be written as what, beta? I can write it as 1 by 5 or not? You'll get it as 1 by 5. So I can take initial momentum will be minus delta p into 100 divided by zero point 0.2. So what is our initial momentum, beta? Minus 500 delta p will be our initial momentum. What is minus sign indicating? Inverse proportionality, guys. So whenever momentum is changing, they have said the error or the change in the de Broglie wavelength is 0.2%. Right. So what is the initial momentum they're asking? Please remember this formula. Wavelength will be given as, de Broglie wavelength will be given as h by mv or h by p or h by root over 2mk or h by root over 2mq into v. Right. This is how you give de Broglie wavelength. Right. If you know these two formulas, all questions from dual nature you will be able to solve, guys. Understood, all of you? Yes or no? Then let us see next question. When photon of when a photon of frequency nu falls on a metal plate of work function phi naught, the photoelectrons of maximum kinetic energy k are ejected. If the frequency of radiation is tripled, what will happen to maximum kinetic energy? Please remember, guys, kinetic energy and frequency will follow a straight line. Stopping potential and frequency will also follow a straight line, but that straight line doesn't pass through origin. If it was passing through origin, if kinetic energy was tripled or if frequency was tripled, kinetic energy would have been tripled, right? If frequency was doubled, kinetic energy would have been doubled. When? If that was following a straight line passing through origin. But is kinetic energy frequency graph or stopping potential frequency graph, are they following a straight line passing through origin? No, they have a certain intercept, guys. Because the intercept is negative, if frequency is doubled, kinetic energy will become more than doubled. If frequency is tripled, kinetic energy will be more than tripled. If frequency is becoming 4 times, kinetic energy will become more than 4 times. Suppose if the intercept was positive, guys, then if frequency was doubled, kinetic energy would be less than doubled. Right? Triple, less than triple. Quadruple, less than quadruple. So if kinetic energy, frequency, stopping potential, frequency graph, if they were following a straight line passing through origin, agar frequency doubled, तो kinetic energy doubled. If it is following a straight line with positive intercept, frequency doubled means kinetic energy less than doubled. If it is following a straight line with negative intercept, frequency is doubled means kinetic energy will be more than doubled, guys. So always remember, it's a very important case. If you see current versus, just now I've told you, current versus intensity, is it following a straight line passing through origin? Yes, it is following a straight line with, with passing through origin. So if intensity is doubled, current will be doubled again. If intensity is tripled, current will be tripled again. Okay, so that is how we take it. However, if you want to solve this question, maximum, very basic case again, maximum kinetic energy is given as h nu minus phi naught. What is maximum kinetic energy given as? K will be h nu minus phi naught. So from this, I will write h nu value as k plus phi naught. In next case, what they are saying? They are saying frequency is tripled. So what I'll get, h nu naught minus phi naught will turn, which is going to turn out to be minus phi naught. So what will this be? 3 h nu minus phi naught. Now in place of h nu, What I am going to substitute beta? In place of h nu, I'll substitute this. So if I substitute it, what are we going to get? New kinetic energy will be k plus phi naught minus phi naught, which turns out to be 3k plus 3 phi naught minus phi naught, which will be 3k plus 2 phi naught, guys. This will be our new kinetic energy. Clear, everyone? Because kinetic energy versus frequency follows a straight line with negative intercept. If variable is changed, let us say it is doubled or tripled or quadrupled, or it became 5 times, then what will happen to kinetic energy? It will be more than doubled or more than tripled or more than quadrupled or more than 5 times. Clear, all of you? It's a very important case again. In the same manner, de Broglie wavelength of an electron in fourth Bohr's orbit is related to the radius. How will you write again? De Broglie wavelength will be given as 2 pi r divided by n. Right? This is de Broglie wavelength for what beta? For an electron in nth Bohr's orbit, guys. For an electron in nth Bohr's orbit, it is the de Broglie wavelength. So what I can write? They are saying in fourth Bohr orbit. So what is the de Broglie wavelength? So 2 pi r divided by 4 you can write, which turns out to be pi r divided by 2. This also you should remember again. Okay. Okay, so let us see. Which of the following graphs represents the variation of speed of proton and wavelength? Speed and wavelength, it seems, guys. Here speed is taken on y-axis. So we know lambda will be given as h by mv. So v value will be given as h by m lambda. So as I can say, y will be inversely proportional, or v will be inversely proportional to lambda. So which graph? Y is inversely proportional to x, means which graph will it follow, beta? It follows a rectangular hyperbola. Kya bola? Rectangular hyperbola. So first graph will be the answer for that. I hope it is clear, everyone. Next case you see. An electron which has a mass m and charge minus e is moving with an initial velocity v naught j cap. So it is moving in which direction? Electron is given, beta. Electron is given, means obviously it is negative charge. Where is it moving? It is moving in y direction. It is entering an electric field. How is the electric field? As you can see, the electric field is in downward direction. E naught minus j cap, guys. Now always remember, whenever a negative charged particle is placed in an external field, what is it going to experience, beta? Whenever a negative charged particle is placed in an external field, what will it experience? It will experience a force opposite to the direction of field. So force experienced by the electron will be E times of E naught. Now they are asking what is the de Broglie wavelength associated with an electron at t is equal to t. So here you see, is it constant acceleration? Yes, E value is not changing. E naught value is also not changing. So what would be the acceleration here? Because it's an unbalanced force, guys. Usually we neglect the weight. Gravitational force is weakest force. So in comparison with electric force, we will not consider gravitational force, guys. So what is given? Initial de Broglie wavelength is given. So I can write lambda naught value as h by v naught. This is initial de Broglie wavelength. Now, is there some net force acting? Yes, on the electron there is some net force acting, which is E naught. So I can write net force as mass times of acceleration. So what will acceleration be? It is a previous year question, beta. E naught divided by m. Is it constant acceleration or not? Yes, it is constant acceleration. So what I can apply? Because it is constant acceleration, I can apply v bar is equal to u bar plus a bar into t. So let us assume velocity. So whenever velocity and acceleration are in same direction, how will the object move? In the direction of velocity with increasing speed, beta. With what speed? With increasing speed. So here v value will be more than v naught. Let us imagine this is the situation at t is equal to 0. This will be the situation after t is equal to t seconds. So what I can write? It will be v naught plus e naught divided by m into t. Clear? So what will our new wavelength be? New de Broglie wavelength, if they are asking. So lambda, if I say, it will be h divided by m into v. Now how can I write v value as, beta? I can write it as v naught plus e naught divided by m into t. Let us take V naught common. What are we going to get? 1 plus E naught divided by mv naught into t. Right? And what did we get already? This value? We already got h by mv naught as our lambda naught, guys. So what we will write lambda value as? It will be lambda naught divided by the previous year question again. Lambda naught divided by 1 plus E naught divided by mv naught into t. Very important case. Suppose if electric field was in the direction of velocity, then in denominator you would have got minus, guys. As simple as that. In denominator you would have got minus again. Clear all of you? Here you are getting plus because the electron is moving opposite direction of electric field. So whenever a negative charge is placed in an external field, it will experience a force opposite to direction of field. Whenever a positive charge is placed in a field, external field, it will experience a force in the direction of field. These things we have studied again, right, in your electrostatics part, guys. I hope you understood the question. What they are saying, electron and neutron have same momentum, it seems. The ratio of their respective de Broglie wavelengths they are asking. See, what is wavelength again given as? H by P. H is anyhow constant value. Now, for electron, it is given as H by Pe. For neutron, it is given as H by Pn. Now, as Pe value will be equal to Pn, momentum of electron and momentum of neutron are same, they have given. So, I can say lambda of electron will be equal to lambda of neutron. So, what is the ratio of lambda of electron to lambda of neutron, beta? It will be 1:1. Clear, everyone? I hope it is clear. I see. Work function for metals are given x, y, and z. 2.5, 4.28, 3.3. Out of these three metals, which is most photosensitive? Which will be most photosensitive out of these three metals, guys?
X.
Whichever has least work function. So X will be most photosensitive. Which will be least, guys? Which will be least photosensitive? Y will be least photosensitive. Why? Because it has, out of the given values, it has more work function. So now what they are saying, the maximum kinetic energy of electrons emitted for the respective metal surfaces are in the order. Again, basic logic, maximum kinetic energy will be energy of incident light, which is h nu minus phi naught. Whichever has less value of work function, will the electrons emitted have more kinetic energy for such metal or not? Yes, what I can write, kx will be greater than kz will be greater than ky. Yes or no, all of you? Direct question again. Choose the incorrect statement for photocell, it seems, guys. Photocell is that particular device which is used to convert the light energy into electrical energy, guys. Photocell is that device which converts light energy into electrical energy. So what they are saying, these are used for detection of traffic law defaulters. Yes, photocell is used to detect the traffic law defaulters. To increase the photocurrent, a photocell is filled with suitable inert gas. Yes, guys, it is also correct. It is a device which converts electrical energy into light energy. No, it is a device which converts light energy into electrical energy, guys. This helps in counting the person entering an auditorium. Yes. Which one will be wrong statement here? This one. Okay. So to increase, this is also previous year question. To increase the photocurrent, a photocell is filled with suitable inert gas, guys. Okay. Next, photoelectric effect supports quantum nature of light. Cause photoelectric effect is an instantaneous process. Yes, it is an instantaneous process. Actually, to say it is a spontaneous process. There is a minimum frequency of light below which no photoelectrons are emitted. Yes, what is that value? Minimum frequency below which no photoelectric effect. Threshold frequency. Maximum kinetic energy of photoelectrons depends on intensity. Does it depend on intensity? No. Photoelectric effect is an instantaneous process. Rather than saying instantaneous, you can say it is a spontaneous process. What is the meaning of spontaneous process? As soon as the light is incident, soon after the light is incident, without any time lag, electrons are going to be emitted, guys. Almost a time lag of less than 10 power minus 9 seconds. Right? So both first statement and second statement are correct statements. Supports quantum nature of light because photoelectric effect is an instantaneous process, or to be precise, it is a spontaneous process, and it will be a minimum frequency of light below which no photoelectric effect will be taking place. That frequency is called as threshold frequency. So here in this case, both first and second one will be true, guys. Clear, all of you? Work function of cesium is given as 2.14 electrovolt. Right, for cesium it is given as 2.14. What is cesium? Just now I have told you cesium is most photosensitive because it has least value of work function. Which is least photosensitive, guys? Platinum. Why? 5.65 electrovolt, highest value again. That is the reason it is least photosensitive. So they are saying work function is given. What is threshold frequency? What is the expression for work function? It is h nu naught or hc divided by lambda naught, guys. So what we can also write this as, they're asking us to find threshold frequency. So I can write this as phi naught divided by h. Phi naught value is 2.14. Electrovolt is given, so I can write 1 electrovolt is nothing but 1.6 into 10 power minus 19 joules. And h value, what will it be, beta? 6.6 into 10 power minus 34 joule second you can write. So if you solve for this, you will get near about how much will this be? This will be 1 by 2, 5 point something you will get, guys, into 10 power 15, I think. If you just, this will be near about 1 by 2 you will get, because this value will be 3, or more, just more than 3. 3 by 6 if you take, guys, it will be 1 by 2, which is 0.5. So you'll get it as near about 0.5 into 10 power minus 34. If you send into numerator, it will become 15 hertz, to which I can write it as 5.16 into 10 power 14 hertz, guys. Clear, all of you? Right? Threshold frequency can be written as work function divided by h. H is a Planck's constant. Its value will always be same. Its value will always be constant. 6.6 into 10 power minus 34 joule second, guys. How to convert electrovolt into joules? 1 electrovolt will be 1.6 into 10 power minus 19 joule. Right? And how to, what is this? This is joule second, guys. Which of the following has maximum stopping potential when metal is illuminated by visible light? Right? When metal is illuminated by visible light, what do we write? V naught value, we have studied, it is hc divided by lambda naught, we can write, or hc divided by E into lambda naught. As you can see, stopping potential will be inversely proportional to wavelength. So whichever has less value of wavelength, I think you all are aware, EV naught value is given as hc by lambda minus hc by lambda naught, or you can write it as phi naught only. Simply, if you want to write phi naught, you can write phi naught. So what is stopping potential? hc divided by E lambda minus phi naught divided by. They are saying which of the following has maximum stopping potential when the metal is illuminated by visible light. Visible light means 7 different colors again. Which will have maximum stopping potential? For V naught to be more. For V naught to be more, what should lambda be? Because they're inversely proportional, lambda should be less. So out of the given option, which one will have least value of lambda, guys? Obviously, we know violet is going to have least value of lambda again. Clear, everyone? The theory on which photoelectric effect can be explained. Which theory? Right. We have two theories, guys, again. One is wave theory, other is particle theory. Right. So based on quantum theory, we can consider. What is the de Broglie wavelength associated with an electron moving under a potential difference of 10,000 volt. Always remember wavelength for electron is 12.27 divided by root V angstrom. Voltage should be taken in volts, guys. What will it be for proton? For proton, how much is it, beta? It is 0.286 divided by root V in angstrom. What will it be for alpha particle? It is 0.101 divided by root V angstrom. If you want to remember it directly. Or if not, you can simply remember it is h by mv or h by p or h by root over 2mk or h by root over 2mq into v. So what will it be for electron, beta? 12.27 divided by, I can write 10 power 4 here. So what will I get 10 power 4 as? I'll get it as 10 square under root again, which is angstrom. So what are we going to get here? I can write it as 12.27. Angstrom is nothing but 10 power minus 10. If you send this into numerator, you'll get it as 10 power minus 12 meters, guys. Or I can write it as 0.1227 into 10 power minus 9 meters, which turns out to be 0.1227 nanometer, guys. 0.01. I've forgotten one more zero here. So you'll get it as 0.01227. 0.01227 nanometer will be the wavelength associated with your electron. क्या कर रहा हूँ भाई मैं? Understood, everyone? Please remember, if you want to remember in shortcut way, guys, you can remember it like this. Wavelength of an electron will be 12.27 divided by root V, and voltage should be taken in volts, guys. Then you will get the answer in angstrom. Okay. Maximum kinetic energy of emitted electrons depends on frequency of incident light. When the frequency of incident photons is, what they are saying, maximum kinetic energy depends on frequency of incident of incident photon. Okay, obviously when frequency of incident photons is equal to threshold frequency, half of threshold frequency, greater than threshold when is this, when will it depend? Basically when photoelectric effect is taking place. So it should definitely be greater than threshold frequency, guys. When will photoelectric effect take place? If frequency is more than threshold frequency and wavelength is less than threshold wavelength. In these two cases, photoelectric effect takes place. And is it necessary that if frequency is more than threshold frequency, photoelectric effect will take place? Not necessary, guys. Right? Because efficiency of photoelectric effect is how much? 1%. It indicates it is not necessary that even if frequency of incident light is more than threshold frequency, or wavelength of incident light is less than threshold wavelength, or energy of incident light is more than work function, right? Will electrons be emitted compulsorily? No, there is no compulsion again for that. I hope it is clear, all of you. When is it true? When will kinetic energy depend on frequency? Only when frequency of incident light is more than threshold frequency, or only when photoelectric effect takes place. They're asking identify the correct relation for the given graph, guys. Now you see here in this case, all the currents are same, beta. What are same? Currents are same. So I1 value will be equal to I2 value will be equal to I3 value. What I can tell regarding intensities? Again, intensity and current are directly related with each other. So I1 will be greater than I2 will be greater than I3. Now what are stopping potentials? Stopping potentials are negative potentials, guys. Here what do we have? V0, sorry, intensities. If currents are same, means intensities obviously will be same. Now as you can see, stopping potential for 3 is more than that for 2, more than that for 1. So what I can tell, frequency in third light will be more than in second light will be more than that in first light, guys. Nu3 greater than nu2 greater than nu1. Currents are same here. Currents and intensities will be proportional to each other. Current is related with intensity. So as currents are equal, it is clearly indicating that intensity of the incident lights will also be equal. However, if you look at the diagram, stopping potentials are different. So whichever has more stopping potential, that will have more frequency. Understood? Stopping potential is the negative potential, guys. They are saying graph shows, graph below shows variation of de Broglie wavelength for three charged particles of equal charges but different masses. Okay. So what we can write h value as lambda value as h by root over 2m qv. Yes or no? For same charges. For same charges, guys. Or in general, can I write it something like this? Wavelength value will be h by root over 2mq into 1 by root v. Can I write or not? So where is wavelength represented? On y-axis. Where is 1 by root v represented? On x-axis. So is it following y is equal to mx? So it is a straight line passing through origin. So let us say in this case, whose slope is greater? Whose slope is greater, beta? Slope of B greater than slope of C greater than slope of A. Charges are same. So if charge, this is the slope again. We'll get this as the slope. Charges are same. H will anyhow be same. More slope means definitely will mass be less or not, guys. So implies mass in B will be less than mass in C will be less than mass in A, guys. So MB, which will be greater, MA is greater than MC will be greater than MB. Clear all of you? Understood everyone? Now, there is a particle, it seems, which has been dropped from a height h. The de Broglie wavelength of the particle as a function of height just before it reaches the ground. So, whenever an object is dropped from a certain height h, what is going to happen, beta? Will it be moving under the effect of gravity or not? So, just before it hits the ground, with what speed is it going to hit the ground? It will hit the ground with the speed root over 2gh. Do you remember this, all of you? So, if it is initially dropped, it will be moving under the effect of gravity. So, they are asking just before it reaches the ground, what is the de Broglie wavelength? So, what I can write? H by mv you can write, which will be h by m into what is the speed with which it will hit the ground? So I can say de Broglie wavelength will be inversely proportional to square root of h, or I can say it is inversely proportional to h power 1 by 2, implies lambda value will be h power minus 1 divided by 2. Clear everyone? Understood all of you? Next. If temperature is increased from 27 degrees Celsius to 127 degrees Celsius, what is the ratio of de Broglie wavelength of wave associated with a material particle at these two temperatures? Now, we know wavelength, de Broglie wavelength in terms of kinetic energy is given as h by root over 2mk. Now, this kinetic energy, in kinetic theory of gases, we study about it, guys. We can also represent it in terms of your temperature, guys. So how will you write this? If you consider only translational modes, then from kinetic interpretation of temperature, I can write kinetic energy as 3 by 2 into kb into t. Or I can directly write here wavelength associated with particles. Relation with temperature, if I see, guys, it will be h by root over 3m kb into t, where kb happens to be your Boltzmann constant. T should be temperature in Kelvin, guys, absolute temperature. So here wavelength is what? Inversely proportional to square root of temperature. So lambda 1 to lambda 2, if I say, it will be root over T2 divided by T1. Temperature should be taken in Kelvin. So initially it is 27, means 300 Kelvin. 127 means 400, guys. So what will I get here? 400 divided by 300, which I'll get it as root over 4 by 3, which is 2 divided by root 3. They're asking the ratio of de Broglie wavelengths of associated. So lambda 1 by lambda 2 only they're asking, guys. So I can also write this as lambda 1 by lambda 2 can be written as 2 root 3 divided by 3. So root 3 is 1.7, so I can write it as 5.4. 1.732 you will get, which can be taken as 5.464 divided by 3, which will be 1.732. How much will I get? 24 means 8 you will get, no? Why there is no option? Did I do any mistake? 400 by 300, 2 by root 3, 2 root 3 by 3. 1.732, no? 4, 6, 14. This 3.464, guys. So I'll get it as 1.155 approximately. Okay. Wavelength, de Broglie wavelength will be inversely proportional to square root of absolute temperature. You should take temperature in Kelvin, guys. Okay. Next question, if you see, there are two sources of light, each emitting power of 100 watt. One emits X-rays of wavelength 1 nanometer, other visible light at 500 nanometer. What is the ratio of number of photons of X-rays to photons of visible light of given wavelength? Now power is given. Do they have same power, beta? What is power? Power is given as energy per unit time. One photon is there, energy will be h nu divided by t. Like that, if I say n number of photons is there, you will write n into h nu by t. They're asking number of photons. What is the ratio of number of photons of X-rays to photons of visible light of a given wavelength? So if I take number, guys, it will be power into time divided by h nu. Or we can write power into time into lambda divided by hc. Power is same, time is same, h value will be same, c value will be same. So what I can say, beta? Number will be to here for same power, because both are giving same power, guys. For same power and time, because h and c are anyhow constant values. For same power and time, number of photons emitted will be directly proportional to lambda. So I can write n1 divided by n2 will be equal to lambda 1 divided by lambda 2. So they're asking number of photons of X-rays. So X-rays of wavelength, what is the wavelength? 1 nanometer. Visible light of wavelength 500 nanometer. So what will be the ratio of photons emitted, beta? Will be 1 is to 100 again. Direct case, guys. 1 is to 500. Power will be given as energy per unit time. If you have one photon, you will write h nu by t, guys. But if you and n number of photons are emitted, then I can write power as n into h nu divided by t. So I can write number of photons emitted as p lambda by hc into time. Or usually they will ask you number of photons emitted per unit time, guys. N by t they will ask. N by t will be p by hc or p lambda divided by hc. Very important case again. Next question. Light of wavelength 500 nanometer falls on a metal of work function 1.9 electrovolt. Stopping potential they are asking, guys. So what will be the situation here? Very direct question. What is stopping potential given as? It is given as hc divided by e lambda minus phi naught divided by e. Okay. So what we can write again, hc value if I consider, it can be written as 12,400, guys. What I can write? 12,400. That too in angstrom you will get. So what is the meaning of 500 nanometer? It means it is 5,000 angstrom, guys. So what I can write this hc by e value? I can write it as 12,400 beta. So I'll write this as 12,400 divided by wavelength. I should take in what? Angstrom. So I'll get this value because this is voltage again. I'll get this in volt. Minus of phi naught divided by E. This also will get it in volts only. So overall answer will be in volts, guys, again. Hc value is basically 12,400 electrovolt. Hc by E value will be 12,400 volts, guys. But provided lambda should be taken in angstrom again. So what I will get? 12,400 divided by 5,000 minus phi naught value is given as 1.9 electrovolt divided by E. So obviously E and E will get cancelled out. 0, 0 gaya, 0, 0 gaya. So you will get it as 12.4 divided by 5 minus 1.9. 12.4 will be 2.24 you will get. So you can take it is 2.48, I guess, minus 1.9, which will be 0.58 volt, guys. Understood, everyone? Direct question again. Clear, all of you? This question is also very important again. Momentum they have given. Momentum relation with intensity you should find, guys. Momentum of a photon in a beam of light of wavelength 6,000 angstrom. So what is lambda value? Lambda value, we know it is given as h by p. Right? Energy, if I say, guys, energy, how will I write? We'll write it as hc divided by lambda or not. From this, what we can tell momentum as? Momentum can be written as h by lambda. So what we can write here, this I can write as p into c. So what is momentum, guys? If wavelength is given, momentum is how much? H by lambda. But if energy is given, then it will be E divided by C, guys. They're asking uh, momentum of a photon in a beam of light of wavelength 6,000 angstrom. Intensity is given. What is the momentum they are asking? So wavelength is given. For us, there is no necessity of intensity here, guys. So because wavelength is given directly, we can find it out. So what will momentum be? H value, you know, it is 6.6 into 10 power minus 34 divided by 6,000 angstrom is there. So I can write as 6 into 10 power minus 7, guys. So I'll get it as 1.1 into 10 power minus 27 kg meter per second. Clear, all of you? So if wavelength is given, momentum will be h by lambda. If energy is given, momentum can be given as E divided by C, guys. Very important. Both the formulas are important formulas again. Momentum is h by lambda, momentum is E by C. Yes.
So if we wanted the relation for intensity, then how would
What is intensity? It is energy transmitted per unit time per unit area.
yes,
What
sir.
is intensity? Energy transmitted per unit time or per unit area you can write. So I can write E value as I into A into T divided by C. Or I can write it as energy. This is in terms of power also you can write. I into A will be nothing but power. So power into time divided by C you can write. Okay. So different ways are there in which you can write that. Which of the following is incorrect regarding photoelectric effect? It is based on particle nature of light. Correct statement. Stopping potential depends on intensity of incident light having fixed frequency. No. Stopping potential depend on frequency only, guys. Saturation current depends on intensity of incident light having fixed frequency. Yes. Frequency should be greater than threshold frequency for emission of electron. Yes. Which is wrong statement here. Second statement. Stopping potential and kinetic energy will depend only on what? Frequency. Clear, all of you? If you see, an electron is accelerated through a potential difference of 64. What is the de Broglie wavelength? Just now we have seen wavelength associated with electron will be 12.27 divided by root V. You will get the answer in angstrom. You should take V value in volts, guys. So I can write it as 12.27 divided by root 64, which is 12.27 divided by 8, which will be 1 point. You will get near about 42, which is 527. You will get 1.53 angstrom. Clear, everyone? That will be the de Broglie wavelength. Ratio of momentum of an electron and an alpha particle which are accelerated from rest by a potential difference of 1 kilovolt they are asking. So what is momentum generally? H by root over ratio of momentum they are asking, guys. Ratio of momentum of a, so how can you write momentum? It is root over 2mk, or I can write root over 2mq into V. Okay, potential difference is same again. So for same potential difference, what will momentum depend on? Momentum will be proportional to root m into q. They're asking us momentum of electron to momentum of alpha particle, which will be root over mass of electron divided by mass of alpha particle, charge of electron divided by charge of alpha particle. Clear, all of you? Yes or no? So what will you get? Masses in terms of masses are given. Charge of electron is 1 e. Charge of alpha particle is 2 e. So I'll get it as mass of electron, mass of alpha particle e divided by 2e, which I'll write me divided by 2 into m alpha. This will be the ratio of momentum of electron and momentum of alpha particle, provided they are accelerated by same potential difference. Clear? What does the Davidson-Germer experiment do? It is an experiment which is used to experimentally verify the wave nature of electron, guys. So it is the evidence of wave nature of electron again. Clear, all of you? What will be the ratio of de Broglie wavelength of a proton and alpha particle of same kinetic energy? Again, what is de Broglie wavelength? H by root over 2mk. Yes or no? For same kinetic energy, what we can tell regarding de Broglie wavelength? It will be inversely proportional to square root of mass. So wavelength of proton to wavelength of alpha particle will be mass of alpha particle divided by mass of proton. You know mass of alpha particle is 4u. Mass of proton is 1u. So I'll get it as root over 4 is to 1, which will be 2 is to 1. Clear, all of you? What does photo cell do? It converts electrical energy into light energy. Just now we have seen. Next question, if you see, five very important case, guys. Definitely such type of questions can be asked. 5% of energy supplied to a bulb is radiated as visible light. So only 5% of the energy supplied by the bulb, guys. How many photons are emitted per second by 100-watt bulb they are saying? Right? So power is given as 100 watt. It means, can I write it as energy per unit time? 100 watt? Yes or no? But what do you see? 5% of the energy supplied to a bulb is radiated as visible light. So if the bulb has a power 100 watt, this is your input power. So what will be efficiency here? 5% only. So what we can write the output power, if I say, it will be 5% of the input power, which is 5% of 100 watt. What is 5% of 100 watt, beta? It is 5 watt only. Yes or no? So the output power that we are going to get will be 5 watt. Now what they are asking? They are asking us to find out the power anyhow is given as 100 watt, guys. They are asking how many photons will be emitted per second by 100 watt bulb, but out of this 100 watt bulb only 5% is utilized again. So how can I write power as? So you can take it as this output power can be taken as energy emitted per unit time. N photons are there. You can write h nu divided by t. So what I can write n by t as, beta? Output power divided by h nu. Now what is given to us? Lambda is given. So I can write it as output power. Nu can be written as hc by lambda. No? So this will be the value, guys. How much is output power? 5. What is wavelength here? If you multiply by 100 and divide by 100, or 1000 by 1000 if you do, you will get it as 5600 angstrom. And how can I take hc value? Hc value I can take it as 12,400, guys. If you want to write 12,400, but in electrovolt you will get, guys. Okay. So what will this be? 12,400 electrovolt you will get. So I can write 1.6 into 10 power minus 19. Okay. No, sir, we want to directly do as it is. We don't want to do in different way. Then you can opt for doing. See, you can do problems in any way, guys. This 5 watt wavelength is 5.6 into 10 power minus 7. H value, as you all know, it is 6.6 into 10 power minus 34. C value is 3 into 10 power 8. So you'll get 19.8 in denominator. In numerator, you will get it as 28 divided by denominator will be 19.8. Here 10 power minus 26 you will get. If it is sent into numerator, it will become 10 power 19, guys. So near about 7 by 5 you will get, which will be 1.4. Okay, so approximately 1.4 into 10 power 19 photons will be emitted per unit time, guys. Clear, everyone? Above threshold frequency, when photoelectric emission takes place, time lag between incidence and photoelectric emission. Just now I've told you. Just now we were talking about a term called as instantaneous. There I said photoelectric effect is a spontaneous process. What is the meaning of it? When light is incident, as soon as light is incident, it will take very much less time for electrons to get emitted. How much less time? 10 power minus 9 seconds, or even lesser than that, guys. Clear, all of you? Yes or no, everyone? These were some questions which I thought of discussing from your. Yes, Harshit.
Sir, in that photoelectric cell question, it
Hmm.
converts light energy into electrical energy.
Acha, I wrote electrical into light.
Yes, sir.
I said, I think. Array. Converts light energy into electrical energy, guys. These were some questions which I thought of discussing from dual nature, right? So we can take the class for some more time, guys, and we will move on to atoms, right? However, if you look at, if you want me to give the review of dual nature, I'll try giving the review. Any of your choice, guys. Shall we go with atoms? In dual nature, you will have these things only. Either you will get de Broglie wavelength case, or you are going to get photoelectric effect, guys. No other question will be asked from this particular chapter. Directly we can guess the question, guys, either from this or from that. I don't think there is a necessary. There is a necessity. Yes, no.
So would you be able to give a review? I mean, when we
Review
are
of,
doing, so
huh?
when we are doing the
You,
nuclear.
you said no already. I remember a few things.
Okay,
मेरी उतनी तो basic memory है. Right. Let us do some questions of atoms again. Maybe till 10 o'clock, 15 minutes. We will just do whatever are possible. The rest we will see tomorrow, guys. So I have already activated the test. It will be active from 10 o'clock, 10:30, maybe 10 o'clock today, I guess. Whatever time I have specified, right? It will be active from that time till tomorrow. I have given because I thought I may not complete atoms today. So that is the reason I've given it. Anyway, you can cross check it, guys. Once tomorrow we can have some little bit extra time. So we are left out with, today is Tuesday already, right? So we are left out with 3 days again, right? So in those 3 days, till tomorrow, we will do nuclei. Day after tomorrow, we will do electronic devices and circuits. Till tomorrow, I'll complete nuclei for sure, guys. Day after tomorrow, we'll do electronic devices and circuits because it's a very big chapter. It will take some time again, right? On Friday, what I'll do is I'll take the heat cases again. So whichever are important in heat, I will tell you. Okay, but right now, after the class, I will share all the brief notes, and some people have also asked for assignment, but that assignment is basically in order to score more marks in physics again, right? Not basic marks. So that was the situation. However, I'll share the assignment also if possible. Mostly by tomorrow, I'll share all the assignments I have shared for optics. I think second year topics I have shared, guys. First year topics I have not shared, so I'll try sharing those also, right? And apart from that, I would request you people to go through electromagnetic waves. Initially, I kept electromagnetic waves also in the schedule, guys, but because for some or the other reason, I was not able to take it. Somewhere we were getting some clash in the days, so I removed that electromagnetic waves. But electromagnetic waves is also important chapter, very silly chapter. It can just be completed in half an hour, and you can expect 2 questions from that also, guys. Okay, so it's very important from that aspect. Now we'll do some questions of atoms probably till 10 o'clock. The hydrogen atom in ground state absorbs 12.75 electrovolt of energy. The orbital angular momentum of electron is increased by. The basic thing, orbital angular momentum, you know, it is given as mvr, and in case of Bohr's model, we can write it as nh divided by 2 pi. So whenever it is making a transition from, it is absorbing 12.75 of energy, it seems, guys. So what is situation here? We need to take different energy levels again. So this is your ground state, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6. This you have studied in chemistry also. In ground state, you will have minus 13.6 electrovolt. For hydrogen atom, I'm talking about, guys. Then we will have 3.4 electrovolt. Then I will have minus 1.51 electrovolt, I believe. Then I will have, because divide by 9 it is, so we'll get it as something like that. Then by 16, if I divide, I think you will get it as how much, guys? 0.8, no? I hope so. 0.85 electrovolt you will get. 0.58, I guess. 0.54 or 58. I'm not sure exactly. You just cross check it. Then you have 0.38, 0.28 electrovolt, something like this. Now they are saying that the electron has absorbed 12.75 electrovolt where it is from ground state. So from ground state, it has absorbed 12.75. It means automatically it is moving from ground state to fourth state or not, guys? Because if you see the difference in the energy levels, final energy is how much? Minus 0.85. Minus of initial energy is minus 13.6. So I can write 13.6 minus 0.85. So how much will this turn around, guys? Correct only? Did I take 16? You will get, I think, whatever it is, huh? So 15 you will get. This is correct only, I guess, no? 12.75 only you will get, right? This you will get as 12.75. So from where to where is it shifting, guys? It is making a transition from ground state to fourth state. Fourth state is also called as third excited state. So what is initial angular momentum in ground state? H by 2 pi. Final angular momentum, it will become 4h divided by 2 pi. They are asking us angular momentum is increased by. So what is the change in angular momentum? Final angular momentum minus initial angular momentum. 4h by 2 pi minus h divided by 2 pi, which you will get it as 3h divided by 2 pi, guys. Right? 2 pi is also around 6, guys. So you will get near about 3.16. 3.16 into 10 power minus 34 joule second will be the increase in the angular momentum. Clear, all of you? Among which of the following, for which transition of hydrogen atom, photon of lowest wavelength are emitted, guys? Always remember, whenever electron makes a transition from one energy level to another energy level, either it will absorb energy or it will emit energy. The energy absorbed or emitted will always be equal to difference in the energies of the energy levels, guys. Now you see, lowest wavelength. So when we talk about energy again, energy is given as h nu. Energy is directly proportional to frequency and inversely proportional to wavelength. Which one will have less wavelength? Which has more energy. Now more energy, you see, when transition is made from 2 to 1, right? When it is making a emission transition, 2 to 1 means how much energy will be released? 10.2 electrovolt energy is released. When it is making a transition from 4 to 3, you see, 4 to 3, how much will it be? 0.66, I believe, if I'm not wrong with my calculations, guys. 0.66 or maybe point yeah, 1.5, 0.66 somewhere you will get. Yes, or 1.51 minus 0.85 if you do, right? So you'll get it as 14, yes, 0.66 electrovolt you will get here. 3 to 1, if you see from here to here, when it is making a transition from 3 to 1, guys, you will get it as 12.1 electrovolt. When it is making a transition from 4 to 1, just now we have seen it is 12.75 electrovolt. So in which transition energy emitted is more? Fourth transition. So wavelength will be less, guys. Clear, all of you? In Rutherford experiment, if the angle of deviation is given as 180 degrees, then what is the impact parameter? So basically, what is the meaning of impact parameter, beta? Whenever we talk about impact parameters, let us say this is the nucleus of the atom. Imagine this to be the central line passing through the nucleus. Alpha particle scattering experiment, if I take, this is our alpha particle whose mass is m, right? Charge will be, you can take 2e again. This is your alpha particle. It is projected with some speed v, let us say, guys. This is the central line passing through the nucleus, right? This happens to the initial velocity vector. So what is impact parameter? It is distance between the central line passing through the nucleus as well as the initial velocity vector, guys. Now, when will angle of deviation be 180 degrees? Angle of deviation is 180 degrees, means in this case, the alpha particle is moving head on to the nucleus. So if alpha particle is moving head on to the nucleus, what will impact parameter become? Impact parameter will become 0. So here deviation will be 180 if alpha particle moves head on into the nucleus. So when it is moving head on into the nucleus, it means its velocity vector is along the central line. When velocity vector is along the central line, distance between the velocity vector and central line will be 0, which is called as your impact parameter again. For K alpha X-ray, element number is given as 41, has a wavelength of 0.7 angstrom. Then wavelength of the corresponding radiation for wavelength for an element 29 will be how much they're asking. You can use this. You can find the question by using Moseley's law, guys. Moseley's law is applicable for characteristic X-rays only, and he gave a relation between frequency as well as atomic number. Root nu will be proportional to z. So what I can write here? Can I write frequency is inversely proportional to wavelength or not? What I can write, beta? 1 by root lambda will be proportional to z. So what I'll get, z1 divided by z2 will be equal to root over lambda 2 by lambda 1. Or I can write frequency will be proportional to what? Z square, you can say. Basically, you will get frequency as a into z minus b. Okay, root nu is equal to a into z minus b, we will write. So what will I get frequency as? I'll get it as a into z minus b whole square. Okay, a square into, where a value is basically given as for K alpha X-ray, it is root over 3 RC by 4, and b value will be 1, guys. So what in general we can say? I'll not write all this. From Moseley's law, we can say frequency of characteristic X-ray will be proportional to the atomic number. So I can write frequency is proportional to z square. Or I can also write 1 by lambda will be proportional to z square. So z1 square divided by z2 square will be equal to lambda 2 divided by lambda 1. They're asking lambda 2 value, I can write it as lambda 1 into z1 divided by z2 whole square. Lambda 1 is given as 0.7, z1 is 41, z2 is 29 whole square. So almost 40 by 30 if you take, guys, you will get 4 by 3, 16 by 9 you will get. So near about 1.4 something you should get as the answer, guys. 1.43 angstrom will be the answer for this. Clear, everyone? Yes or no? Then velocity of electron moving in nth orbit of hydrogen atom is given as c n power p, where c is the speed of light. The value of k and p are how much they are asking, right? In nth orbit they are saying, guys. So basically we can write c value as c velocity in nth orbit, as you know, it will be given as how much, beta? Z by n times of v naught. Yes or no? So what we can take Vn value as, it will be Z by n, and basically V naught value will be C by 137, guys. Okay, so here I can write velocity in nth orbit will be Z into C by 137 n power minus 1. If you just compare, what will k value be? 137. And what will p value be? It will be minus 1, guys. Why? Because v naught value happens to be 2.2 into 10 power 6 meter per second. Okay, so I can write it as c by z. C by k you can take. C value is 3.3 into 10 power 8. So if you just solve for that, you will get the value as approximately 137. Okay. Then what they have given in next question. If the ionization energy of an electron in ground state is given 13.6, then energy of He plus ion in first state. Always remember, we have something called as ionization or energy in nth orbit. If I say basically, is given as n square by z into E naught beta, where E naught is energy in ground state. Okay, so what will be first excited state? It means it is second state, guys. So they are asking second state in He plus ion. So what is the ionization energy in this? It means electron which is present in the second state, I need to remove it. So what is the energy possessed by the electron in second state? What we can write? E2 in, I can write it as 2 square divided by Z value will be 2 because it is helium, guys, into minus 13.6 electrovolt. Yes or no? So what will I get? 2 times of first excited state they have given, no? First excited state means second state only. If ionization energy of an electron in ground state, sorry, छी क्या लिख दिया रे भाई मैं? What is energy in n state, beta? It is z square divided by n square, no yaar? Yes or no? Z square by n square, right? So what I'll get energy in second state as? Z value will be 2 square divided by 2 square only again, which I'll get it as minus 13.6 electrovolt. So how much is the energy in second state? In second state of He plus ion, energy is minus 13.6. I want to remove. In order to remove the electron, means I need to send that electron to infinity. At infinity, we'll assume it to be 0. So how much energy I should give? I should give plus 13.6 electrovolt, guys. So the ionization energy will be 13.6 electrovolt for the electron present in first excited state of He plus ion. Understood, all of you? If I want to remove the electron, it means I have to make the energy 0. Already electron has this much energy. In order to make this energy 0, should I give addition plus energy or not, guys? Clear, all of you? What is the shortest wavelength of Fund series they are saying? Always remember wavelength of the photon emitted during the transition from one energy level to another energy level will be given by Rydberg's formula, which is 1 by lambda r into 1 by n1 square minus 1 by n2 square into z square. Z square for hydrogen-like atoms. What is n1 here? Principal quantum number of that orbit into which it is making transition. And this would be principal quantum number of that orbit from which it is making transition. So for Fund series, guys, although in basically they'll ask you Lyman Balmer or Passion, guys, right? Lyman Balmer, Passion, bracket and Fund. For Fund series n value, it will make a transition into which state? Into fifth state, guys. Lyman, Balmer, Passion, bracket, Fund. So what will be our case here? The wavelength of photon emitted will be given as 1 by phi square minus 1 by n2 square into z square. So when will shortest wavelength, when will you get shortest wavelength, guys? When emission is taking place from infinity to the given state. So for shortest wavelength, what we can write here? For shortest wavelength, n2 value should be infinity beta. When will you obtain longest wavelength? When the transition is made just from the above state to the given state. So in Lyman series, the shortest wavelength will be obtained when transition is made from infinity to 1. In Balmer series, infinity to 2. In Passion series, infinity to 3, shortest wavelength. Longest wavelength, guys, when transition is made from just above level. So for Lyman series, 2 to 1. For Balmer, 3 to 2. For passion, 4 to 3. For bracket, 5 to 4. For fund, 6 to 5. So here in this situation, I'll get 1 by lambda as r into 1 by 5 square minus 1 by infinity square. Hydrogen atom is given, so I can take it as 1, guys. Anything divided by infinity would be 0 only. So I'll get r divided by 25 as 1 by lambda, implies lambda value will be 25 divided by r. And 1 by r value will be 912 angstrom, guys. 25 divided by r. We'll do one more question. An electron is excited to nth excited energy state. Nth excited energy state. So nth excited state, you can say, in a hydrogen atom. Then the number of spectral lines emitted will be from grounds, from first nth excited state means first excited state is second state, no? So what is nth excited state? Will principal quantum number be n plus 1 here, guys? And then number of possible number of spectral lines emitted. So when it is making a transition from nth state to ground state, or what is the general formula? When it is making a transition from nth state to mth state, beta, number of spectral lines emitted will be n minus m into n minus m plus 1 divided by 2. Okay. In this case, what are we going to get? It is making a transition from n plus 1 to which state? Ground state. What will I get here? N plus 1 minus 1 plus 1 divided by 2. So what will this be? From here, what are we going to get? This will be n. This will be n plus 1 divided by 2. Okay. So n into n plus 1 by 2 will be the answer. Right. So rest of the questions of, you are already aware of atomic structure. Right. Those who are interested in solving the test, please solve the test, guys. It is already active. Right. Those who think that, sir, no, we will do it after completion of the questions, you can wait till tomorrow, guys. Tomorrow we will complete left out questions of atoms and nuclei chapter. Day after tomorrow I'll complete electron device and circuits. On Friday I'll just discuss the important topics of heat, guys. Right? You have in transmission of heat, conduction is there, radiation is there, calorimetry is there in thermal properties. In thermodynamics, different thermodynamic processes are there. However, I'll share the whole brief notes today only. Till kinetic theory of gases, I'll share it today itself. Okay. So tomorrow we'll meet, and tomorrow we will try to take more time. And probably tomorrow and day after tomorrow, I'll take more time, guys. Friday and Saturday, I'm not going to disturb you people by taking more time. So by Thursday, I'll try my best to wind up everything. Okay. So, ji sir.
So in the first question which we did in the atoms, so we have so you had drawn the energy levels, but can't we just do it rightly because we have to remember the values?
If you no, you remember, you do.
So what if I don't remember the values and I want to solve it? I mean, if I want to find the n value in this
It
case.
is just basic case. No, energy in nth level will be for hydrogen like atom. It is z square by n square into E naught. E naught value will be minus 13.6. So in first state minus 13.6. Second state minus 13.6 by 4. Third state minus 13.6 by 9. Fourth state minus 13.6 by 16. Like that.
But still have to draw this thing and have to solve
Not
it.
necessary, no. You can directly solve here only. It is just for representation purpose I have drawn. Clear?
So yeah, matlab ki, I mean, but still have to take out all the values and then I have to understand that whether it is going from this level to the other level.
You basically remember these values in chemistry, no?
Yes, sir.
Here, now what is the problem? If you know the energy, if you know the difference in energy levels, or if you know the energy in the different energy levels, then only I can say from which state to which state it is making transition. And it is important to know.
Yes, sir. Clear.
Right. So we will be meeting tomorrow. We'll complete atoms and nuclei. On Thursday, we will complete electron device and circuits. Okay. So if possible, I'll wind up there itself. If not, we will discuss some important topics on heat, guys, on Friday. Okay.
Sir,
Yes, sir.
sir, can you take some extra time and give just review of electromagnetic waves?
Electromagnetic waves review.
Just review of electromagnetic waves.
Let us see. If possible, we will give.
Okay, sir.
అంటున్నాను. అరే హర్షిత్ ఏం రా నువ్వు నకరాలు చేస్తున్నావు బాగా. నువ్వే పంపిస్తున్నావు లేకపోతే ఎవరైనా వేరే వాళ్ళు పంపిస్తుర్రా? Right. So I have tried to share the solutions to the doubts that you have shared, guys. Right. Today I got little bit free time, so I've shared those solutions. If you have any doubt, please send them. Right. I'll make myself available by hook or by crook, whatever it is, in whatever work I may be busy, or but I'll certainly take out time for you people, guys, especially in the next 3 days. Right. Saturday I'll connect with you people, but I'll keep that very less again. Okay. So that's it from my end for today. If you have any kind of doubt, please do share. I'll certainly share the solutions with you people. Right. Most probably by tomorrow afternoon, something like that. Okay. So that's it from my end. Take care, everyone. Thank you all. Bye bye, all of you.
Thank you, sir.
Thank you, guys.